I'm Tara from Blockwise Engineering, and in this video we're going to go over training for the Blockwise LX stent loader. The LX is a fully automated machine, and it's capable of loading a variety of self-expanding stents and stent grafts. To start out training, we'll want to discuss the layout of the machine and all of its components. So first up, let's talk about the compression station. The compression station is the part of the machine that will be responsible for crimping your stent. In this case, the station is 225 millimeters long, and it has a maximum diameter of 30 millimeters. The station is opened and closed by an electric motor. It has a maximum radial force of 1,435 newtons. The dies are the 12 components that make up the bore of the station. We have a few different options for the material that you want the dies to be made out of. You can choose either PEEK with PTFE, PEEK with carbon fiber, or Light TX. The next part of the machine is the touchscreen HMI, which is a convenient interface for controlling the machine and programming and storing up to 500 recipes for all of your various products. The machine also has what's called a clamshell gripper. This is the attachment that's used for holding your catheter and bringing it forward to the station to keep it in alignment during the loading process. The carrier slides forward along this guide rail and it self-centers with the opening. Then it's locked into place. The auto pushrod system is another attachment available for this machine. Its job is to hold a pushrod and guide it forward during the loading process in order to help expel the stent from the station. Using this attachment helps to put continuous forward force on the stent in order to help move it into the catheter. Lastly, the LX also has an available liquid nitrogen cooling option. There's two configurations for this option, and the most common, the one that you see here in this picture, is the catheter cooling option. This option will direct a stream of liquid nitrogen onto the stent just before it's pushed into the catheter. The purpose of cooling is to maintain the compressed state of the stent during the loading process in order to try to reduce friction. So that's it for the general layout of the machine and the options that are available, but now let's get into some specifics about these components. First, we should discuss the clamshell gripper. The clamshell gripper aligns the catheter with the crimped stent inside of the compression station. It firmly holds the catheter during the loading process. The carrier will need to have custom tooling made to hold your specific product. So this includes the grips, which hold the catheter and prevent it from slipping during loading, as well as the bushing that aligns the catheter with the opening of the station. The grippers are custom molded pieces of silicone that fit inside the carrier and are sized a little below the outer diameter of your catheter. The carrier will also need to have a custom sized alignment bushing. This will have a hole drilled in it that is also sized to the outer diameter of your catheter. If your machine has liquid nitrogen cooling, then the bushing will need to be stepped in order to allow the liquid nitrogen to reach the stent before it enters your catheter. Before using the clamshell gripper, you'll have to install the custom tooling. First, insert the rubber grippers, ensuring they're fully seated into the carrier. Next, insert the alignment bushing into the clamp on the front of the gripper. To ensure that the bushing will meet the face of the dies during loading, set the machine's diameter to 1 millimeter. Then, move the gripper into position with the alignment bushing still loosely held. At this point, push the bushing forward to ensure that it is touching the face of the dies. Then, you can tighten the two 832 screws on the clamp to hold the bushing in place. With the tooling installed, you can go ahead and place the catheter into the clamshell gripper. First, slide the distal end of the catheter into the alignment bushing. If you have a through bushing, then the front edge of the catheter should be flush with the front of the bushing. If you have a stepped bushing, Then you should insert the catheter until you feel it stop against the inside step of the bushing. The catheter should slide smoothly into the bushing, but it should not be loose, since its purpose is to hold the catheter in precise alignment with the station. It is important that the catheter and the alignment bushing are accurately placed. This will prevent a gap between the compression station and the catheter during the loading process. Next, press the catheter into the bottom channel of the silicone gripper. This channel should be a snug fit in order to prevent slippage. You will notice that the gripper is held very loosely on the machine. This is intentional. When it is moved into the forward position, its nose cone mates with the entrance funnel, and the gripper is pulled into alignment with the opening. Now that we've talked about the basic usage of the clamshell gripper, let's talk about the auto pushrod system. The auto pushrod system holds a pushrod and translates force through the rod onto the distal end of the stent in order to propel the stent through the station. To attach a pushrod, you will place it in the jaws of the pushrod holder and turn the knob to clamp it in place. If your pushrod has a small diameter and is at risk of buckling, simply attach the anti-buckling assembly to the system. Then you can insert the pushrod through the anti-buckling assembly before tightening the knob to clamp the rod in place. The auto pushrod system gives force, position, and speed feedback. This ensures that you can control the force as well as the placement of your stent inside the catheter. To attach the system to the main base, install the two 1032 flathead screws and connect the loader motor and loader force connection onto the machine side panel. The machine should always be off when connecting or disconnecting the attachment. We should also talk about the liquid nitrogen cooling options. This is a very helpful option if you want your stent to maintain its compressed size during the entire loading process. To install the system, you'll need to connect the insulated lines from the LN2 delivery port at the front of the station to the single fitting labeled LN2 out. On the cooling box, there's a T fitting labeled into gas out. Connect the provided insulated lines from this fitting to the two fittings on the back of the station. Lastly, you'll need to connect the cooling box to the cooling power connection on the side of the machine. Remember to always have the machine turned off when connecting or disconnecting. You can now connect your liquid nitrogen source to the cooling box. The inlet is a 1/4 inch NPT fitting. During a cooling step, the liquid nitrogen will flow from your source through the phase separator inside of the cooling box. The liquid line will then be directed to the front of the station, where it will flow directly on the stent just before it enters the catheter. The gas lines will then be directed to the back of the station, where they promote a dry environment and help to reduce condensation. Okay, now we've kind of discussed all the attachments to the machine, so let's delve into the HMI. Let's talk about how to control the machine and how to start programming recipes. The touchscreen is really easy to operate and intuitive. You can use this machine either in a manual control or a recipe control. For manual control, what we'll want to do is be on the setup screen here, and you can see down here there's a manual mode button. So that's what you will want to click. And then it takes you to this screen where you can enter a manual diameter and press go, or you can enter the force that you want to crimp to and press go. And then that will make the machine actually move to the diameter that you have set it to. So if I set it to 5 and I push go, then it'll start to reduce the diameter down to 5 millimeters. You can see that I get both diameter and force feedback from the machine as it's moving. For full control of the process settings, you're actually going to want to create a recipe. This will allow you to create a series of consecutive steps that fully automate the entire loading process. To create a new recipe, we will, from the setup screen here, we'll want to push the Run Screen button down here in the bottom left-hand corner. After you push that button, it will bring you here to the recipe screen. You can first choose which recipe you want to have open by selecting the recipe number button up here in the top right-hand corner. Once you've selected the recipe that you want to use or edit, you can proceed to the recipe edit screen by selecting Modify Recipe down here in the bottom right-hand corner. So the next screen that you come to after you click Modify Recipe is this General Recipe Settings screen. Everything on this page relates to the recipe as a whole. Firstly, you can rename your recipe here. Additionally, you can choose to increase or decrease the pressure to the clamshell gripper, which will change your clamping force on your catheter. You can also set the cooling duty cycle that's here. This is just a setting that dictates the percentage of time that the liquid nitrogen is flowing during your loading process if you're using liquid nitrogen cooling. Then you have the loader stall speed. This is essentially a lower speed limit for the auto pushrod loader. It tells the machine how slow you will allow the pusher to move during the loading process before it stalls out. Then lastly, this setting here is the loader offset. So this is the initial position of the loader at the beginning of a recipe. There are a number of limits here, but I would like to come back and discuss those after we've moved ahead and discussed the step types that are available to you in the loading process. So once you're ready to start your recipe, you're going to need to know how to add steps. So if we click this button here, we'll have the option of programming in how many steps we want to have in our recipe. You can also choose this Insert Step button to insert a single step into any location on the recipe. You can do the same to delete steps. You can select delete a step and then tell it which step you want to delete. You could also reduce this number of steps here, and that will that'll delete steps off of the end of the recipe to reduce down to the number you programmed in. So now that you've populated your recipe with steps, you'll want to start changing the step types. So what we're going to do here is first select the name of the step type. Just by clicking on it, you can change the type. You can then push select the setting field, and it'll bring up this keypad so that you can change the setting. So once you've built the recipe that you want, you can simply choose Save Changes here in the bottom left-hand corner. After you've clicked Save Changes, you'll come back to the recipe run screen. The recipe is loaded and ready for you to use. Now that we've talked about how to actually add the steps, let's talk about all the available step types and how you would want to use them. In the LX manual, you'll find this table that lists all of the step types available for your machine. We can discuss them, the main ones here. So the first one here, the diameter step type, is a way of controlling the compression station diameter. So with this setting, you can tell the machine that you want it to crimp to a given diameter, and it will crimp that small regardless of the force needed to crimp your stent down to that size. Conversely, you could choose to use a force-controlled step, in which case you're telling the machine how hard you want to crimp on the stent, and then it will end up at whatever diameter is necessary to maintain or to reach that force set point. The next two settings, the load speed and the load step, are both settings that control the auto pushrod loader. In the first case, the load speed step tells the machine is a control for how quickly the auto pushrod loader is moving. So the set point here, which would be setting number 1, your load speed, is telling the machine that you want it to travel that fast regardless of how hard it has to push on your stent to maintain that speed. Setting number 2 would be the distance that you want it to travel. Conversely, if you choose the load force step, you'll be controlling the force that the pushrod puts against your stent. In this case, setting 1 would be that force, and the machine will run with whatever run at whatever speed is necessary to maintain that force. Setting 2 would again be the distance that you want it to travel. Then we have the cooling step type. So this step type is either an on or an off setting. When you turn the cooling on, you can also set a temperature that you want the station or the system to reach before it moves on to the next step type. It's important to remember that this setting is not a temperature controlled setting for the loading process. This temperature setting is simply telling the machine that you want it to reach this temperature before it moves on with the rest of the loading process. During the duration of the loading process, what's controlling the flow of the liquid nitrogen is the duty cycle setting that you set in the general recipes settings box. The next two step types are the verify force and verify diameter. These are simply check steps that allow you to set a minimum and a maximum limit range on either your diameter or your force, and the machine will check to verify that the crimped state of your stent is within either that diameter or that force range. If it fails, it will give you a warning to let you know that your stent is not within your limited range. Before we go back to the recipe that we just programmed, let's back up a step to the general recipe settings screen that we were on earlier, because I mentioned that we would come back to this box of limits. And now that we've talked about the step types, we can come back and talk about these limits. So remember I said that if you choose to control the diameter of your station, then it will crimp with whatever force is necessary to reach that diameter. However, it's likely you're going to want to limit the force that your stent experiences, and so you would do that here with this setting. If you have a crimp force step and you're controlling the force of your station, you may want to also put a minimum limit on your diameter, in which case you would set that here. Similarly, for the auto pushrod loader, we have some limitations as well. If you're using a load speed step, which controls the speed of the loader, but not the force, you may want to limit the force that your stent experiences. On the other hand, if you are using a force controlled step, then you may want to limit the speed or the rate at which your loader travels while maintaining that force. Okay, now that we've discussed kind of all the step types and their various settings, let's go back and look at this recipe that I programmed earlier in the video, and we can talk about what I've created here. So step number 0, this is the diameter step, the initial diameter step. So this step always exists in your recipe, and it's always a diameter step. You do have the option of changing what that initial diameter is, but again, this is just telling the machine what diameter to return to at the beginning of every new cycle. I've programmed in step 1 to be a diameter step of 5 millimeters. So this is just a rapid movement step. I've kept it at 10 millimeters a second, and its purpose is to come from 25 millimeters down to 5 millimeters quickly, so I don't have to wait for the machine to move all that distance. Then I've programmed in a force step. Again, this is still a compression step, but now rather than controlling the diameter as I was doing in this step, I'm controlling the force, and I'm telling the station to crimp on my stent with 40 newtons of force. The third step I've programmed is just a load speed step. So this is this loading step is what initiates the auto pushrod loader to start moving forward. It also initiates the power feed if you have the power feed option. And I'm simply telling the machine that I wanted to move at 2 millimeters per second because, again, I'm controlling the speed. And I wanted to move for a distance of 100 millimeters. Now you can just push the green start button on the machine to get the recipe started. First, we're doing a 5 millimeter diameter step. Then it moves on to a fourth step. So the machine is slowly reducing its size until it starts to crimp on the stent. Then we'll see the force jump up. Once it hits 40 newtons, it moves on to the load speed step. We can see that the loader is moving forward, and it's trying to maintain this speed of 2 millimeters per second. And that means that we have a 14 Newton pushing force on the loader right now as we're maintaining that speed. We can see it's still just plugging along, and it's just going to maintain this step until it reaches our set point of 100 millimeters. Then that'll be the end of the recipe. So at that point, the machine will open back up to that initial diameter step that we set in our original as step 0 on our recipe. Okay, so that's sort of the basic training for how to program recipes for use on the machine. Now, there's a few other settings I'd like to just go over real quick. So we've seen this screen a few times, but we haven't really talked about any of these settings yet. These are all general machine settings, so each of these things applies to the machine as a whole. First, you'll see that there's a units box where you can select various units for the measurements that are shown on the machine. For force, if you select this button, you can toggle between showing force in newtons or in pounds. For diameter and length measurements, you can select either millimeters or inches. And for pressure settings, pressure readings, you can set it to either read in bar or PSI. Then there's the calibration box. So on this machine, you can calibrate the diameter of the compression station. You can calibrate the crimping force of the compression station. You can calibrate the pressure of the clamshell gripper. And you can calibrate the loader force. This is for the auto pushrod loader attachment. There's a few other buttons here. The View Cal Values button shows you the current calibrations in the machine. And this Set Safe Cal Values is a calibration reset, sort of a factory reset button that will clear calibrations back to factory safe settings. Then we have the security box. In here is where you will switch user access modes. So you can be logged in as an admin, an operator, a calibration tech, or an engineer. And the various user access modes limit the availability of settings in the machine. So you can refer to your manual to see which settings are available under which user access mode. One other thing I want to point out here is this data export button. You can use this to have the data, the feedback data from your recipe exported during the loading process. And then, of course, the manual mode button and the run screen button were the buttons we selected to navigate either to manual mode or to our recipe control. And that'll conclude our basic training for the Blockwise LX stent loader. There's more information regarding specific loading techniques, process development techniques on our website in the knowledge base. You can also always reach out directly to us, and we'll be happy to answer any of your questions.